Carbon capture and storage is a technology to help reduce emissions of carbon dioxide into the atmosphere. Unlike the other technologies that one could use to do this, it is the only one that will allow us to continue to use our fossil energy resources while not emitting the CO2 into the atmosphere, but storing it underground instead. Technology to remove carbon dioxide from industrial plants have existed since the 1930s, and we've been pipelining and injecting CO2 in the ground since the 1970s. The industries that would use carbon capture and storage are the ones that emit the most CO2. The biggest single type of industry is coal-fired power plants, but there are other industries such as gas-fired power plants, refineries, hydrocarbon production, cement plants, iron and steel. While all industrial processes have some inherent risk, carbon dioxide capture and storage, or as we call it, CCS, is a relatively safe process. One of the main reasons for this is we're dealing with the gas carbon dioxide, or CO2, which is non-flammable, non-toxic, and non-explosive. We're going to look in geologic formations, specifically depleted fields from production of oil and gas, or deep saline formations that have no commercial value. In North America, the United States Department of Energy has had a program to develop CCS technologies for the past 15 years. A lot of it is laboratory and modeling and pilot plant work, and recently a number of demonstration projects have been put into place, and a couple of them are in operation now, and a few more will be coming online over the next few years. The first large-scale CCS project, and by large scale we mean 1 million tons a year or more, was started in 1996 in the North Sea by Statoil, called the Sleipner Project. Since then, about 3 other projects have come on and from industrial sources about the same size. Recently, 2 projects are now being developed and are under construction in North America at power plants, and these will be the first 2 CCS from power plants, one in Mississippi and the other in Canada. With CCS available, we can cut the costs for reducing CO2 emissions in the future by about 50%. Today, CCS technologies are reducing emissions by millions of tons a year. However, to really make an impact, it has to reduce emissions by billions of tons a year. So getting from millions of tons a year to billions of tons a year is going to take a driver to create markets, and that driver is going to be climate policy. I think the biggest challenge facing CCS now and trying to do these large demonstration projects is getting the financing in place. So I think it's because these projects are expensive. They could cost $1 billion or more, and to come up with the financing without climate policy being in place makes it very difficult. If we put a price on carbon dioxide emissions, and that price is high enough to encourage all sorts of low carbon solutions into the marketplace, like nuclear energy, like renewable energy, along with CCS, then I think you would see a competition that CCS could do very well. I think CCS is very competitive against other low carbon technologies.